Hi, I'm Dr. Henry Black. I'm an adjunct professor of medicine at the Langone New York University School of Medicine, and I'm here today with my friend and colleague, Dr. Dan Levy. Dan, thank you very much. Now, you've been at Framingham a long time. Could you tell us a little bit about how Framingham started and where it's going now?
Sure. At the beginning of the 20th century, the three leading causes of death in the United States were pneumonia, tuberculosis, and infectious diarrhea. By the midpoint of the 20th century, heart disease had catapulted to become the leading cause of death. Yet, even though it was claiming so many lives each year, remarkably little was known about its underlying causes. By 1948, Congress set aside a small amount of money to study the epidemiology of coronary heart disease and other forms of cardiovascular disease. And they chose the town of Framingham, Massachusetts for that study.
Why was that?
Well, it's a complicated story with a little bit of politics to it, but one of the advisors to the National Institutes of Health back then was Paul Dudley White, probably the most prominent cardiologist in the United States at that time, and he was quite eager to have that study in his backyard where he can participate in it.
And he was at Mass General then, right?
He was at Massachusetts General Hospital and Harvard Medical School.
Right. So it began then as I think 5,209 individuals from Framingham. And what's happened since?
So it began with the question of monitoring a large population, following it for a long period of time, repeating observations over time until enough people developed cardiovascular disease to gain some insights into measurements measured at baseline and the occurrence of disease over time. When the study began, by the way, it was estimated that it would take 20 years of follow-up of those initially healthy 5,000 people to have enough events to create some of those links.
What sort of risk factors, a concept that Framingham had developed, were actually studied then?
By the late 1950s, some of the clues became apparent, and in 1961, Bill Cannell and Roy Dawber, Joe Stokes, a few other well-known people in the field, wrote the first major impact paper from the Framingham Heart Study. It was called Factors of Risk in the Development of Coronary Heart Disease. That was 1961, and in that paper they identified high blood pressure, high cholesterol levels, and left ventricular hypertrophy on the electrocardiogram.
And there was no interest at that point or talk at that point about obesity or diabetes or family history. When was that entered in?
These other risk factors came in over time. In fact, it was a few years before cigarette smoking, for example, entered the list of risk factors. And that was because so many of the male participants in the study, when it began, smoked. It was so difficult to identify non-smokers and demonstrate a gradient of risk from non-smokers to smokers.
Now, how many men and how many women were originally?
It was almost identical numbers of men and women when the study began.
So that was understood at the beginning that we also had to study women. That wasn't a later phenomenon.
Well, it was interesting, Henry. It was not so much to determine what the factors of risk were for heart disease in women, but rather to figure out what protected women from developing heart disease. But obviously, with longer and longer follow-up, it became apparent that women, too, were succumbing to heart disease more than any other condition.
Was there a focus on stroke as well, then?
So the focus on stroke really began to emerge in the mid to late 1960s, in part through Paul Dudley White's insistence that there was much still to be learned in Framingham as the population aged and entered an age of stroke. So stroke became a focus of the study about 20 years after the study began.
Now, you and I wrote what I guess we'd call a little position paper about the importance of systolic pressure compared to diastolic pressure. And yet, I believe it was 1971 where Framingham was one of the first, if not the first, epidemiological survey to indicate that systolic was a better predictor. How's that happened? What's happened since?
Well, we've had a number of projects now looking separately at systolic and diastolic blood pressure, refining a little bit more about when one predicts and the other predicts less, etc. And it's quite clear that diastolic is still useful in very young people. When the diastolic pressure is quite elevated, that's a risk factor. In the elderly, it is the systolic pressure that's the better predictor, as you know so well. And more importantly, hypertension in the elderly is far more common than hypertension in people at very young ages. So overall, beyond 50 years of age, the single most common form of hypertension is isolated systolic hypertension.
I was always wondering how that happened, and my own guess was that when you're looking at young people and someone comes in with a hypertensive crisis who's 180 over 140, you're going to focus on the diastolic, compared to an older person, usually a woman, who was 220 over 80 and seemed fine. So it seemed relatively obvious that it was the diastolic pressure. And yet, I think it didn't take long as we began to observe this, it was very much age dependent.
Very much age dependent. You know, you can go back to, in fact, life insurance tables that look at blood pressure levels and old textbooks that will tell you that the increase in systolic hypertension with age is part of the normative aging process, leading to people to believe that it was normal and expected and acceptable as well.
100 plus your age was the mantra I was taught, maybe you as well, but that certainly wasn't the case. Now, what's going on right now in Framingham?
Well, we're doing a lot of new things, and in fact, the Framingham study today is so different from Framingham at its origin, it would be almost unrecognizable. Much of the work that we're doing today is focused on genetics and genomics, DNA sequence information across the entire genome in increasingly large numbers of people, exome sequencing the coding parts of our DNA, that's about 1% of the entire genome, in growing numbers of people. We were pioneers in genome-wide association studies looking at common genetic variation across the human genome and disease. And we're going from the level of DNA to the RNA that the DNA codes for, with transcriptomic studies looking at changes in RNA expression related to a variety of phenotypes and disease conditions. Looking also at microRNA, very small regulatory particles of RNA. We're also doing studies now in DNA methylation, proteomics and metabolomics, taking advantage of a lot of high throughput omics technologies to apply them in a population setting to better identify new signatures of disease, perhaps long before people develop clinical overt disease.
Now, you're on your third generation now, right?
We are well into our third generation.
So I understand from having met a few of the people who were part of it, how proud they were to be part of that, and I think that's a great thing. We need people to volunteer. We need to thank them, and I don't think we thank them enough.
Yeah, it really is amazing. When we began the recruitment of our third generation participants about a decade ago, almost every day in clinic, one of them would say to our staff, "I've waited my whole life for this day to arrive."
Really?
Because that tradition of volunteerism in their families, they were eager to participate and be part of the study as well. And that notion of altruism, many of us would like to do good things for society but don't have the means to do it, or haven't figured out a way in which their small contribution would make a difference. And I think our study participants feel that their involvement in the Framingham Heart Study is a way they can give back.
Dan, thank you very much, and thank you all.